going to tell the story of a scientific revolution that completely flipped our understanding of reality on its head. And let's start with this. Even the guys who invented the theory, people like Niels Bohr, basically admitted this stuff is baffling. That feeling of shock, that sense that something is deeply, fundamentally weird about the universe, well, that's the whole point of our story today.
You see, to really get why quantum physics was such a bombshell, you first have to understand the world it completely blew apart, the world of what we call classical physics.
For hundreds of years, physics was built on this incredibly simple and beautiful idea that the universe was smooth, continuous, and most importantly, perfectly predictable. If you just knew the starting conditions of something, you could calculate its entire future. No problem.
This idea has a name. It's called determinism. And it was the absolute bedrock of science. The universe was seen as this giant cosmic clock, and if you could just know the exact position and spin of every single gear at one instant, you could, in principle, predict everything that would ever happen. That's how solid the whole thing felt.
In this metaphor of a solid block of ice, it's perfect. It really captures the mindset at the time. By the end of the 19th century, a lot of physicists honestly thought they were pretty much done. But then, they started to notice some very strange cracks starting to appear in that perfect, solid ice.
Right around the turn of the 20th century, a few nagging experimental puzzles started popping up. Little things that the old, comfortable rules just couldn't explain.
It all kicked off with Max Planck. He discovered that energy doesn't flow smoothly like water down a ramp. No, it comes in tiny, distinct packets, which he called quanta. It was more like walking up a staircase. You can be on this step or that step, but never in between. Then a few years later, Albert Einstein comes along and says, you know what? Light itself is made of these packets. And then Niels Bohr applied that same staircase idea to the atom, saying that electrons can't just be anywhere. They're locked into specific energy levels.
So, are you starting to see the pattern here? Energy, light, even the very structure of atoms. At the smallest scales we could look, reality wasn't smooth at all. It was lumpy. Everything seemed to be built out of these fundamental, indivisible chunks called quanta. But here's the thing. Well, it calls for a real revolutionary. Enter Werner Heisenberg. The mystery that was driving everyone absolutely nuts was this. Bohr's model of the atom worked pretty well, but it had this giant glaring hole in it. How on earth does an electron jump from one orbit to another without ever crossing the space in between? I mean, think about that. It's basically teleporting. The old physics had absolutely no answer. So Heisenberg, totally frustrated and struggling, decided to get away. He went to this remote island, Heligoland, and he kept thinking about what his mentor, Bohr, had told him. Don't get bogged down trying to picture things you can't actually see. And that's when he had this incredibly bold, absolutely radical idea. He decided to just stop. Stop trying to visualize the electron's journey. What if we just throw the whole question out the window? What if concepts we take for granted, like a path or a trajectory, just don't apply down there? Instead, he decided to build a new physics from the ground up, using only the things he could actually measure, the raw data. And in this case, that meant the numbers in his tables, the specific frequencies of light that atoms gave off when those electrons jumped. He focused only on what was observable. So what came out of all those frantic late-night calculations on that windy island? It wasn't a nice, neat picture of the atom. Not at all. It was something much, much stranger. A new fundamental law of nature that governs the entire universe. This is Heisenberg's legendary uncertainty principle. And what's absolutely crucial to get is that this isn't about our tools being clumsy or our measurements being bad. It's not a problem we can ever fix with better technology. It's a fundamental feature baked into the very fabric of reality, a built-in fuzziness. Think of it like this. If you take a super fast, crystal clear snapshot of a speeding baseball, you know its position perfectly in that one instant. But you have absolutely zero information about its momentum, which way it's headed or how fast. Now, if you take a blurry long exposure photo, you can see the whole path. You know its momentum, but you can no longer pinpoint its exact location at any one moment. It's a trade-off. You can't have both. And with that one principle, Heisenberg didn't just crack the old worldview, he completely shattered it. He replaced the perfect certainty of classical physics with inherent, unavoidable uncertainty. That solid block of ice didn't just crack, it melted into a bizarre ocean of probabilities.
So, where did this leave everybody? This is the question that has haunted physicists for a century now. If the math only tells us the probability of finding an electron somewhere, what is the electron before we go looking for it? Is it really in many places at once? Does it even have a definite position? The equations work perfectly, but they described a reality that was completely alien to human intuition.
This deep philosophical confusion led to the splintering of ideas, these different interpretations, all trying to tell a story that makes sense of the bizarre math. You have some who say the universe literally splits into infinite parallel copies of itself every time a measurement is made. Others who believe there's a deeper, hidden reality we just haven't found yet. Each one is a totally mind-bending story about the true nature of reality.
Many of the greatest minds of the time, including Einstein, just could not accept that the universe was fundamentally random. He famously hated it, declaring, "God does not play dice." He spent the rest of his life trying to prove quantum mechanics was incomplete. But here's the thing, so far every single experiment we've ever run has proven its strange predictions to be right.
And this brings us right to the heart of why quantum physics is so confusing. It's confusing because Heisenberg's revolution didn't just change the rules, it changed the very questions we're allowed to ask. Maybe reality isn't some fixed, independent thing just sitting out there for us to passively discover. Perhaps it's something that only solidifies through our interaction with it, through observation. More like a conversation between us and the universe. So I'll leave you with that. What do you think?